Hi, this is Jacobit's Learning. We're doing basic geometry shapes. It's just a real quick explanation on the differences between a parallelogram, a trapezoid, and a rhombus. So those are your different shapes. Here's a rhombus, and when you look at it, it has four diagonals. And no matter how you turn it around, um, it's going to have four sides. And as you see here, when you look at this one, the blue one, it's forming more and more like a baseball diamond. And you still have, this means perpendicular, right? Whenever you see this, it's supposed to mean perpendicular, which means they are equal to 90 degrees. Okay, so that's called perpendicular. And whenever you see a shape like this or like a baseball diamond, like what this kind of is, I'm going to show you one on another page, that pretty much tells you what's going on. Okay, so here's a baseball diamond, and you see the same thing. This is just this tilted another way. So if you can look at this from this standpoint, what they did was they turned this around so that you had a shape here, a size here, and you all know I'm not the best drawer, a size here and a size here, and you still have your basic rhombus. Should be straighter here, but it is still pretty much your basic rhombus. Okay, that is going to give you, I'm going to try it a little bit more diagonally. It's going to try to give you like a baseball diamond. And here are your cuts, because if you go here and go across, one side should be equal to the other side. And a rhombus is usually a what? A quadrilateral, which means that it should equal, that is a bad quadrilateral, but let's go ahead and try it again. A quadrilateral is equal to 360 degrees. So when you think about it, if your quadrilateral is equal to 360 degrees, you're going to get 490 angles, 490 degree angles. So that comes out to like this. $90 times 4. And that's what all of these are. Okay, so this one here is 90 degrees. And we put this up here, that just means degrees. This one here is 90. Make it up top, that's 90 degrees. This one here is 90 degrees. And this is 90 degrees. Okay, so now, don't let these confuse you. This is called an irregular shaped polygon. And what's going on here is your angles still have to equal 360. So did you guys get this here? This 360 degrees is what it has to equal. So when you're getting ready to add this up, this is 130, 20 plus 20, and you already know 130 plus 40 is 170. So then all you have to do is get the average. Then all you have to do is get the same, is subtract this 170 from 360, and we did it on the next page. And when you do your 160s, this is just showing you the math behind it. These cancel out. You still have added this, and you got 40 here, and this is plus 130, and then you had 170. But whatever you do to this side, you have to do over here to this side. So if you subtract 170 here, and you get 0, you subtract 170 here, you're going to get, don't forget to borrow, 9. And this is a 2. 2 minus 1 is 190. And so this isn't equal to 0, it's equal to x, because that's what you were trying to solve. And this is 0 plus x and not 0 times x. So it's x equals this number. And there's a way to add that back to see if it equals 360. So we're going to do that. So we're going to do that. If you put 190 plus these two are equal to 40. Zero, 3, carry 1, 230, and then you do 230 plus this 130. Are you doing the mental math? You already know that this is going to come down to a 6. This is a 0. It's 360 degrees. So you did the problem correctly, and that's all you do. A lot of times when we teach students, they get afraid of this. They get afraid of this shape, and they forget to count what it is. And also, people will look at this and say, okay, 1 side, 2 side, 3 side. Oh, that's 5-sided. It's not. This indent in is where it stops here. This is 1 side, 2 side, 3 sides, and 4 sides. Okay, so it's a quadrilateral. And if you just count your sides, you should be okay. Okay, now you go over here. And this is a quadrilateral. And again, I'm a bad drawer, but once again, you're doing your sides. 1, 2, 3, 4. That's 4 sides. So people say, oh, that's a polygon. That's right. Polygon means many. Okay, many sides. Greeks. It's your etymology, many. And gon isn't really sides. It's more like shapes, forms. So many forms. Okay, or many like layers, many angles, whatever, forms. So whatever is more than, and most of the time, like anything that's more than one-sided is a polygon. So then all you'd have to know is your degrees, and if it's a polygon, this angle is equal to this angle, and then you just start looking at it and stop letting the shapes intimidate you. Okay, so the perimeter of this, if you put this here, perimeter is just adding everything around. And you have to think of a perimeter as somebody who's going around. You're going to put some water in a pool, and you want to know how big it's going to be inside here. So if you just took some water and said, I want to know how much is going to fit in here, and you started going, how much is going to be able to get in here? I want to just see if I can go from this side to this side, and if my children, or my dad and I want to go swimming, what am I going to do? And I'm going to go from over here, then I'm going to come walk over here, and while this looks larger, it might be that it's taking up space. So how much could I do? When you get ready to measure the depth of how much someone's going to swim, we think of this as this way, that the perimeter is the outside area. And the outside area, or the outside place, is different than what's going to be inside an area. This is outside. This is outside. It's a round. So we're going to think of this as a round. Everybody got it? It's a round. So perimeter is. Okay? So you're just adding everything around. 5, 2 and 5 is 7, 7 and 5, 2 and 5 is 7, 7 and 4, is 13, and 13 and 4, 2 and 5 is 7, 7 and 4 is 11, and 11 and 4 is 15. Sorry about that. So let's do it again to check. 2 and 4 is 6, 6 and 4 is 10, 10 and 5 is 15. So it's 15. Okay. Polygon is not always four-sided. That's just knowledge for you to know. You can have a pentagon, and that was shown on the first page. But here is where a lot of people get confused. They think because this is all straight here and this is all straight here, then I'm supposed to treat this as if it were a trapezoid. And this is not a trapezoid, this is a parallelogram. And because it is a parallelogram, okay, this and another, even if this area over here is parallel to this, okay, it is still going to be this formula here, which is area equals base times height. Okay, and when area equals base times height, you just simply take this base, which is right here, times this height, which is 6. So we get 6 times 8, and you'd get equals 48. And the problem a lot of students have, and the problem anybody has, like if I don't do this or teach this for a while, you'll forget this, you'll start getting things confused. You just have to know it's base times height, because sometimes they'll take this and make this a triangle, and they'll do like dots down here, and you'll start thinking, I have to know what this area is, it's separate. No, you just have to know the base. If they ask you for the parallelogram, you just have to know what the base is, and the height. And you ignore whatever is going on. If they had a number over here like a 6, you'd ignore this. And they want you to get confused, especially on like standardized tests, because they're testing, do you really know what this is, what the area is? Okay, and that gets confusing. Okay, now when you do a trapezoid, the formula is basically a half base times height. But here's the problem. In a trapezoid, or here's the issue, it gets to be a problem when people forget that there are two bases. So what I would always say is, if you look at this base and look at this base, and they're giving you something, and they're giving you two bases and giving you two formulas, just remember this is parallel to this one. And the only reason that this base may be shorter is, look at that. It's like, it's still parallel. It's like one of those dining room tables that is oblong. It has a real sharp, like, top and tabletop where you eat, but your base is going to be longer. Like people who have TV stands, you have a real short base on the upper base, but then on the lower base it's longer, just so it can hold more. So one may be larger than the other, and people get that confused and say, well, they've got to be the same, because after all, it's a quadrilateral, but it's not an equilateral quadrilateral necessarily. So you have to think about what's going on. So you see your base up here is 20, and this is 14. In reality, this should really be 14, and this should be 20, because this is just a little bit longer, but it kind of looks like they're equal, like just a little bit to the side. But just because we're going over concepts, it doesn't matter. So you have two bases. Base 1 is 14, and base 2 over here is 20, and then times 8. So you put your 8 here, because this is your height. And this is what confuses a lot of people, that your height is actually like the slant where people go up. So if you were a mountain climber, you'd be like, oh, let me climb this, let me climb this, let me climb this, let me get from one base, going to Mount Fuji, let me get to one base and start at the lower back, let me get to this, and then let me get to this. That's why it takes days to do. And that's how you have to think about it. And then like base 1 is 14, and base 2 is 20. Keep it in brackets so that you don't start doing things that will get you off, and don't forget this half, and set up your problem this way. And just try to do as much as you can to let the math speak for you. This is a times, and I'm going to go on ahead and make this a dot. Okay? Now, so you have 20 plus 14 here. This is your area, 20 plus 14. That's 34. This is times 8. This is a half. Okay, and this is now a half of 34 is 17. 17 times 8 is 136. So now you have the area. Okay, if you wanted to do the perimeter, if this were a missing angle here, you'd have to assume that this is 8. Okay, if they asked you for it, you just assume that it was 8, and you just add around. And if not, there would be some kind of formula. So if you added around and you got 34 Guys, this is perimeter, okay? So please don't get it confused. This is perimeter for P. So you'd have 34 plus 8, and really it'd be 34 plus 16, but that's okay. 12, carry my 1, is 42, plus another 8 is going to give you 50. So your perimeter is 50, and your area is usually just a little bit more because it's how much can fill in here. Like think of like how much can fit here. How much water would be here if this were a jar? Well, it would be 136, like, I don't want to say liters, but like centimeters, grams, something you measure, and because you measure gold in grams, like 136 grams, and you'd put something in here that can fit, but what actually goes around is different. So if you just start memorizing the formulas, you should be okay. If you have any questions, please contact us. We're at Jacobit's Learning. Thanks so much for watching.